Good morning all. This is P. Vivek, Assistant Professor, Department of EEE, Velamal Institute of Technology. So today we are going to see about the VI characteristics of various electronic devices. The first device is PN junction diode. So the PN junction diode is a two-terminal device. So it will be having two terminal. One is the anode and another one is the cathode. This is the symbol of the PN junction diode. So here the symbol represents nothing but the arrow mark. So it means the PN junction diode is a unidirectional device so that the current will flow in only one direction. That's why its symbols will be look similar to an arrow mark. So next thing is about the VI characteristics of PN junction diode. So generally the VI characteristics of PN junction diode has two particular regions. One is the forward region and another one is the reverse region. It means the diode will first it will conduct in the forward bias conduction and then the VI, and then the next thing is about the reverse bias condition, how the diode is responding to the reverse bias condition. So forward bias condition means the diode's anode is connected to the positive terminal of the battery and then the cathode is connected to the negative terminal of the battery. So that in the PN region, in the P region, the holes are the majority carrier and then in the N region, the electrons are the majority carrier. So that at the PN junction, there will be a barrier potential. So when we are giving positive potential to the anode and then negative potential to the cathode, the holes in the P region had some barrier to cross over to the next corresponding region, and then the electrons in the N region will have some barrier potential that will affects the PN junction to conduct. Okay, so when we are increasing the forward voltage, after some period the device will start conduct. So that particular point is known as threshold voltage. So it is also known as knee point or cut-in voltage. So the threshold voltage is 0.3 volt for germanium and 0.7 volt for silicon. When we are keep on increasing the forward voltage, the device will start conduct. So this is the forward bias operation. So next one is the reverse bias operation. In the reverse bias operation, the negative terminal of the battery is connected to the anode and then the positive terminal of the battery is connected to the cathode. So that the holes in the P region will be attracted toward the negative region and then the electrons in the N region will be attracted toward the positive terminal of the battery, so that the depletion layer will be gets widened. The width of the depletion layer will be gets widened. Now when we are keep on increasing the reverse voltage, okay, even though in the reverse bias condition the diode will not conduct, there will be some amount of current will be flow. This is due to the minority carriers. So there will be some amount of current flow. You can see that some amount of current flow is there in the reverse bias condition. This is due to the minority carriers. It is this particular current is also known as reverse saturation current. So when we are keep on increasing the reverse voltage, at one point the device will get failed. That particular point is known as breakdown point. So after that the current will increases drastically. You can see that the current is getting increased drastically after some point. That point is known as breakdown voltage or breakdown point. So once it achieves the breakdown point, the device will not it will not be act like a diode, it will act like a conductor. So this was the total VI characteristics of the PN junction diode, and then its features are unidirectional current flow, threshold cut-in voltage, fast switching speed, temperature dependence. So it means that the diode is a unidirectional, so the current flow is also unidirectional, and then threshold cut-in voltage. So even though we will have some other point, from that the device will start conducting. That is known as threshold voltage. fast switching speed. So it means once we are giving the forward voltage, the device may, even we are increasing the corresponding voltage, the device will respond immediately. And then the temperature dependence. So it means the whenever there is some change in temperature, the VI characteristics may affect. Okay. So next thing is about the application of the diode. The diode is used in half wave, both half wave and full wave rectifier, and it will be act as a clipper and clamper circuit, and also it can be used in signal demodulation purpose.